Welcome to the presentation on digital logic families. This presentation covers classification of digital logic families and circuit diagrams and operating conditions of transistor logic. Logic family is a group of compatible ICs having same logic levels and supply voltages. It's fabricated using a specific circuit configuration. Logic family can be broadly classified as bipolar logic family and unipolar logic family. This bipolar logic family can further be classified as saturated bipolar logic family and unsaturated bipolar logic family. The saturated bipolar logic family, the transistors are driven into saturation. The types are direct coupled transistor logic, resistor transistor logic, integrated injection logic, diode transistor logic, high threshold logic, and transistor logic. In non-saturated bipolar logic family, transistors are not driven into saturation. The types are Schottky TTL and emitter coupled logic. In unipolar logic family, the basic elements are MOSFETs. The types are PMOS only, NMOS only, and CMOS. The transistor logic. This logic family was introduced by Texas Instruments in 1964. This is the most widely used logic family of all bipolar ICs. The types are TTL, low power TTL, high speed TTL, Schottky TTL, and low power Schottky TTL. TTL logic family is available in three different output configurations, namely open collector, totem pole, and tri-state. The standard TTL, the basic gate, is constructed with different resistor values. The propagation delay of saturated logic family depends on storage time and RC time constants. In low power TTL, the resistor values are higher than standard TTL to reduce the power dissipation. In high speed TTL, resistor values are lowered to decrease the propagation delay. In Schottky TTL, storage time is removed by preventing the transistor from going into saturation. In low power Schottky TTL, it sacrifices some speed for reduced power dissipation. Power dissipation is 1/5 of the standard TTL. It has the best speed power product. In TTL, there are two series. They are 5400 and 7400. And 7400 devices are used for commercial applications. Temperature range is 0 degree to 70 degrees C. Supply voltage range is 5 volts plus or minus 0.25 volts. The 5400 devices are mainly used for military applications. The temperature range is from minus 55 degree to plus 125 degrees C. The supply voltage range is 5 volts with a tolerance of plus or minus 0.5 volt. The voltage levels are low level corresponds to 0 volt to 0.8 volts and high level corresponds to 2 volts to 5 volts. TTL version in three different configurations are open collector output, totem pole output, and three-state output. So this is a circuit diagram of open collector TTL gate. It consists of 3 transistors and one multi-emitter transistor. It uses multi-emitter transistor in the input, and the basic circuit is a NAND gate. Resistor connected to VCC must be inserted external to the package for the output to pull up to the high voltage level when Q3 is off. Otherwise, the output acts as an open circuit. When all the inputs are high, the transistor Q1 is reverse biased and Q2 and Q3 are saturated. So the output is low level. When one of the inputs is low, the transistor Q1 emitter junction is forward biased and collector junction is reverse biased. So transistors Q2 and Q3 starts turning off. The open collector TTL gate are used for driving a lamp or relay, performing wired logic, and for construction of a common bus system. The totem pole output, the circuit diagram is shown here. The passive pull-up is replaced by an active pull-up in the case of totem pole output. It reduces the propagation delay from 35 nanoseconds to 10 nanoseconds. The passive pull-up consists of a resistor and a capacitor. It's called totem pole because the transistor Q4 sits upon Q3. The application is it's suitable for applications that require fast transition time. The three-state output, it's used in common bus in microcomputers and microprocessors. The difficulties encountered in the other configurations are the totem pole output cannot be connected together because of very large current drain from the supply and consequent heating of ICs. The open collector outputs, when connected with a common collector resistor, externally causes problems of loading and speed of operation. So this is a circuit diagram for a three-state output. So this is the output for different input configuration. When both the inputs are 0, the transistors T1, T4 and T5 are on and T2 and T3 are off. So the output will be high. When one of the inputs is low, the transistors T1, T4 and T5 are on again and T2 and T3 are off. When both the inputs are high, transistors T2, T3, T4 and T5 are on and transistor T1 is off. So the output is 0. When the control input is low, whatever may be the input, the output is open. So that's why it's called as three-state output. It incorporates the advantages of both totem pole and open collector output systems. When the input C is high, when A and B are high, the output is low. When A or B is low, the output is high. When C is low, the output will be floating. In the case of non-saturated bipolar logic family, it uses Schottky TTL. For silicon transistor, for saturation to take place, the base voltage must be 0.7 volt and the collector voltage must be 0.1 volt. In Schottky transistor, for saturation, collector voltage does not fall below 0.4 volts. So transistor is prevented from being completely saturated. Schottky barrier is formed with a combination of metal and N-type semiconductor. Positive voltage to the metal helps overcome the barrier and the diode conducts. Negative voltage to the metal enlarges the barrier and there is no conduction. So only majority carriers are involved in the conduction and so there is no storage time. Schottky transistor is prevented from saturation. In Schottky TTL, the low pass Schottky TTL is the best compromise between higher switching speed and low dissipation. The advanced Schottky TTL is the highest speed in TTL series. The advanced low pass Schottky TTL, the power consumption is very low and the propagation delay is reasonably low. Thank you.